All right, looking at surface areas and volumes of pyramids. Now, of course, a pyramid, as we know what a pyramid looks like. Here we go, here's what a pyramid looks like. A pyramid has a vertex, of course, the vertex of our pyramid. We've also got a base, there's the base of our pyramid. A regular pyramid is a pyramid with a regular polygon as the base. And something that's very misunderstood is the difference between slant height and actual height. If you were to measure the actual distance from the base to the vertex, it would have to be a perpendicular line. That's the height. The slant height follows one of these slanted sides, and that's something different. We will use the slant height today. And you can see right there the slant height is following that side. It's not going straight down to the base. Different things, the slant height and the height. So first of all, the lateral area, yes, lateral area, talking about the faces that are not the base, the area of all these things put together. Well, the lateral area of a regular pyramid is given by our formula where P is the perimeter of the base, L is the slant height. The lateral area is 1/2 times the perimeter times the slant height. What is the lateral area of this regular pentagonal pyramid? Well, if it's a regular pentagonal pyramid and 2 centimeters is one side of the base, the perimeter of the base must be 10 centimeters. Well, we want to find the lateral area, and we know lateral area is 1/2 the perimeter of the base times the slant height. So that's going to be 1/2 times 10 centimeters times our our slant height. Look at that. The slanted height is 5 centimeters. This is going to come out to be 25 square centimeters. Great. The surface area, of course, surface area, just like on all of the solids we've looked at so far, it's going to be the lateral area plus the base. With a cylinder and with a prism, we had 2 bases, and of course with a pyramid, we just have 1. So you find the lateral area, add it to the area of that base. Great. So here it says calculate the total surface area of a regular hexagonal pyramid. Slant height of 12 centimeters, a base that has a side that is 3 centimeters long. So it's a hexagonal pyramid. Try my best. Hexagon here. No, that would be an octagon. Alright, trust me, that's good enough. Alright, there we go. Each side is 3 centimeters long, so we know the perimeter six sides, each one is 3 centimeters long, would have to be 18 centimeters. And so the lateral area, 1/2 the perimeter of the base times the slant height. We've got 1/2 times 18 centimeters times 12 centimeters. We know this gives us 108 square centimeters, clearly. All right, so now we've got our lateral surface area. Remember, we need a total surface area, so we also need the area of our base. Okay, so I have a beautiful regular hexagon drawn here for us. We know since one side is 3 centimeters, we know that all the sides are 3 centimeters. And we need to remember what we've talked about when it comes to finding the area of a regular polygon. We can use our formula, which is 1/2 the apothem times the perimeter. Okay? Because all we have, we got the perimeter already, it's 18 centimeters, but we need that apothem. So if you remember, the apothem is that perpendicular distance to the center of our regular polygon. since it's a regular polygon, that perpendicular distance to the side is going to split that side in half, which means that instead of 3 centimeters all the way across, it's just 1.5 centimeters. It's half of it. And so we're going to use this right triangle here. This is when we have to remember all those things that we talked about before. Because this is a regular hexagon, every single angle is going to be 120 degrees, because we know it's going to be 180 times n minus 2, all divided by n. All of those are 120 degrees, which means that this angle right here is 60 degrees. It is half of that obtuse angle. So this is a 30, 60, 90 right triangle. And if the shortest leg of a 30, 60, 90 right triangle is 1.5, then the longer leg would be 1.5 times the square root of 3. All that work, we got our apothem, we know the perimeter, so we can find the area of the base. The area of the base would be 1/2 our apothem, which is 1.5 times the square root of 3, times our perimeter, which is 18. We plug all this stuff into a calculator. Where's that calculator? There's the calculator. And we type it in. And we get about 23.38 square centimeters. To find the total surface area, we're going to add up those two values, and we get about 131.38 square centimeters. All right, don't be foolish. Remember, 9 times 12 is 108. All right, take a second, try some of these problems right here. I'll wait. I'll give you the answers in about 5, 4. You can always pause it. 3, 4, 3, 2, 1. All right, this first one should be 140 square centimeters. The second one should be about 137.57 square centimeters. Great, we got some practice. Moving on. Taking a look here at this pyramid, the altitude of a pyramid is the perpendicular segment. That's the height, okay? The altitude of a pyramid is the height. It's that perpendicular segment from the base to the vertex. All right, so the volume of our pyramid is going to be 1/3 times the area of the base times the height. Here it says find the volume of our pyramid. The height is 9 inches. We can see that. And the base is a right triangle with legs that are 5 inches and 8 inches long, respectively. Well, if it's a right triangle, we can see one of those sides as the base, one side is the height. I'm just thinking about my triangle down here. The area of this triangle is 1/2 times the base times the height. And so this comes out to be 20 square inches. So we have the area of our base. And now we know for the volume of a pyramid, it's 1/3 times the area of our base times the height, which is 9. This comes out to be 60 cubic inches, because this was inches squared. That's inches, and inches squared times inches gives us inches cubed. This is volume. It's 3 dimensions. Finally, the Louvre pyramid. A regular square pyramid is the main entrance of the Louvre in Paris. It has an approximate height of 70 feet, and its square base sides are 115 feet long. What is the lateral area of the pyramid? All right, we have to remember what they're looking for, the lateral area of the pyramid. Okay, so first of all, it tells us the approximate height. Now let's get this right. What they're actually asking for is the lateral area. For the lateral area, we know that is 1/2 the perimeter of the base times the slant height. That's our formula. So we don't want the actual height. We don't actually need that. So I'm just going to look at the side of this pyramid the actual height going truly down, straight down, is 70. And all the way across our square base is 115, all the way across. So that would mean if we cut 115 in half, $57.5. That, look at this little triangle we're forming. We want that slanted height right there. So this is a Pythagorean theorem situation. I'll call this C. C squared equals 70 squared plus 57.5 squared. And we just solve this. Comes out to be about 90.59 feet about. And we plug these things in. Well, we know the square base 115 times 4 gives us a perimeter of 460 feet. And so our lateral area, 1/2, 460 feet times our lateral area of our slant height of 90.59 feet. We type all this stuff in. We get about 20,835.7 square feet. All right, ready to try some problems? That's what I thought. There you go, take a look at those. I'll give you about 5 seconds to pause this and try those out. All right, here we go. The first one, about 83.3 square feet. Wait, what is this? Is this the nearest tenth of a square foot? Oh, what is this craziness? It's volume. This is cubic feet. That's nonsense. It should be in cubic feet. We find in volume. And the last one there, about 87. What was the rest of that? 237 square feet. That's the book's answers. Hopefully they're correct. That, again, should be cubic